Hello everyone, this is me, Canfield, doing spring break homework. So, this is the only part that you're actually required to do. Here we go. Alright, and I need to make sure that I actually keep all these pages because I'm supposed to upload them to Schoology. And I guess I'll put a link in the description as well, just to make life easier. Alright, let's see. Number 1, we know dy dx is equal to 6 minus 3x squared. And the directions for this is find the general form, or the general solution. It doesn't give us a c value, but it does give us the function. So we're gonna try to finish this and solve it for y. So if I do this and I integrate both sides, then the left-hand side we get y, and the right-hand side we get 6x minus x cubed plus c. Now I need to get y by itself. Oh, I'm done. Number 1 is done. All right, let's move on to number 2. All right, dy dx is equal to 5 root x. So if I separate the variables out, if you've been following along from the beginning, this should feel a little bit insulting how easy this is compared to what we were just doing at the end of the notes. Okay, let's see. So when I integrate both sides, I get y, and then this is 5x to the 1/2. So this is going to be 5x to the 3/2 times 2/3 plus c. So you'd say 10/3. So we'd say y is equal to 10/3 x to the 3/2 plus c. All right, number 3. And again, these are just like, what? I didn't even have to do any separation of variables. Dy dx is equal to 3xy squared. Hey, now we've got to do it. Okay. So, as we separate out the variables, we'll multiply both sides by dx. So we get dy is equal to 3xy squared dx. We got to divide both sides by y squared. So we get 1 over y squared dy. And now we'll integrate both sides. Over on the left-hand side, that's going to give us, well, this is y to the negative 2, right? So we're going to add 1 to the exponent and divide by a new exponent. So we get y to the negative 1 over negative 1. Really bad way to write that, but I'm just, yeah. And then over here, we're getting 3x squared over 2 plus c. I'm going to write c1. And I'm going to go back on what I said and just call it c. Okay, change my mind. Don't want to talk about that. So I need to get y by itself. So let's just, okay, you could stop here. I'm not going to. So this is negative 1 over y is equal to 3x squared over 2 plus c. And there's a little trick that we could employ that I'm not going to use here where we can reciprocate both sides because I think it's going to make less people understanding and make more people confused. So 3x squared over 2 plus c times y. Right, I'm going to multiply both sides by y and then divide both sides by this mess and get negative 1 over 3x squared over 2 plus c is equal to y. I am going to have to multiply this fraction because that's a 2, so we're going to do 2 and then times 2 and then times 2, and we get negative 2 over 6x squared plus 2c, which we could call that a c2 if we want, is equal to y. But yeah. And this is one of those situations where if I was trying to find c, I wouldn't try to find c at the end here. I would try to find c back here, right after we've integrated. That's going to make life so much easier. We find some number here, and then we can go in and do all the mess. So, there. All right. Saving this paper, not throwing it out. That's my BC students. I have a tendency of doing work and then immediately throwing it away. Super unhelpful. All right, question number 4. Question number 4 says dy dx is equal to root x plus x over root y minus y. So if we separate these variables, we get root y minus y dy is equal to root x plus x dx. Those both would have a parenthesis. Oops. Those both would have parentheses around them. Then we're going to integrate. So I just cross multiplied essentially. The left-hand side, that's y to the 1/2, so that's going to be y to the 3/2 times 2/3 minus y squared over 2. And then on the right-hand side, it's going to be very, very similar. We're going to have x to the 3/2 times 2/3 plus x squared over 2 plus c. Good news. I don't know how to solve this for y, so I'm not going to do it. And I'm not expecting you guys to solve it for y. So this would be as solved as I would really expect you to get. Like, sure, we could do more. We could multiply both sides by 6 and clean some stuff up, make it look a little bit nicer. But those are all just kind of aesthetic dressing up to put on this. We're not changing meaning. And just like that, it's like magic. Here's the next problem. So multiply both sides by the dx. Now, to get the y stuff over, we're going to have to multiply by the reciprocal here. We're going to have to multiply both sides by y over the square root of 1 plus y squared. Which at the start might look terrible, but we'll see that there's ways to handle this that make it not so bad. So on the right-hand side, we get our 3x dx, and on the right-hand side, we get monstrosity dy. So when we integrate both sides, integrate, right-hand side's easy. We get our 3x squared over 2 plus c. Left-hand side, we go cry a little bit, and then we come back. So in order to handle the left-hand side, I'm going to do that down here. So if we were taking the integral of why haven't I been using this one? This writes so well. All right, sorry. Square root of 1 plus y squared dy. Okay. Remember, the variable's a dummy. It doesn't matter that it's y's. It just matters that it's kind of weird. This is a u substitution problem. So if I was to set u equal to something here, I want to set u to something where when I take its derivative, when I take the derivative of both sides, I get something really nice. I get something that is present somewhere else in the problem. So my eye was drawn to 1 plus y squared because the derivative of 1 plus y squared is 2y. And you might be like, Canfield, I don't see that anywhere. But remember that this is the integral of 1 over the square root of 1 plus y squared times y times dy. Guys, this is 2 times y times dy. I see that y dy, I see that y dy. They're very, very similar. The only thing I would need to do is multiply both sides by 2 and say 1/2 du is equal to y dy. Or to do the other way, like that Ryan likes to do, and that a lot of you like to do, and I think it's a really good way, is just solve this completely for dy, plug it back in, and do some simplifying. But so when I go in and I plug stuff in, I'm gonna, let's see, 1 over the square root of 1 plus 1. Well, this is my u, so this is 1 over the square root of u. And then I have a 1/2 that I can pull out front, du. Now that's an integral that we can handle. That's 1/2 times the integral of u to the negative 1/2 du. So when I take that integral, I get u to the positive 1/2 times 2 plus c. Oh wait, this is going to be on the left-hand side. So that plus c is not going to be important. But anyway, so the 2's cancel, and we get the square root of u. And remember, the u was the 1 plus, so 1 plus y squared. And so now I can drop that back in. So I can say the square root of 1 plus y squared. So let's talk about the magic that I just did. There was a plus c here. There's a plus c here. But remember that a plus c and a plus c, they're just, it's a constant. It's some random constant. We don't care what it is. And so I can collect them over here. You know, like theoretically, you know, we've got our plus c here, we've got our plus c here, and I'll subtract the c and subtract the c. But it's really like this is c1 over here, and this is c2 over here. And so c1 minus c2, we get some sort of c3. I think you can insert a stupid Star Wars joke there, c3po. But anyway, we get our 1 plus y squared is equal to 3. I'm just going to keep writing this lovely marker. So we could call that plus c3, some constant. And now I want to get y by itself. So I'm going to square both sides, square that, and we get 1 plus y squared is equal to 3x squared over 2 plus c3 squared. Now we're going to have to subtract 1 from both sides, and then take the square root of it. So y is equal to plus or minus the square root of 3x squared over 2 plus c3 squared minus 1. Okay. Don't get caught up in how ugly it is. Get caught up in the fact that we can get y by itself. So a lot of times, I just want to mention this, a lot of times in problems like this, they'll give us an initial condition, and we could have solved for that, you know, back here and found out what C3 is, and then maybe done a little bit more work in simplifying this. But getting a gross answer like this, sometimes it's important to double check like our initial conditions. Like sometimes y is actually not able to be negative, and so we know that we can't use the negative square root. Or other times we know that y is negative, and so we need the negative square root. So it's just something to pay attention to and to be careful of. Oh yeah, and since this is going to go up on Schoology, I need to go and do side work. All right, cool. Number 6. All right, looking at number 6, I don't think I have time to get it done right now. So I will come back and I will continue this exposition. Bye.